Hi, I'm Rohith. So I've recently made a clone of the breakout game. So we'll be looking at how I've made this game and what all features I've implemented. So uh, we'll just start by playing the game once. Uh, so the goal of the game is there are like multiple blocks in the game, right? Let me show you. So these are blocks, and all you have to do is you have to break each and every block using the given ball. And as you can see, the number on the brick indicates how much, like the capacity of the brick, right? So when it reaches zero, the brick breaks. So you have to repeat this until you have got some kind of, like, you have finished breaking all the bricks. So you also saw that I have implemented a power up thing, like a 2x ball power up, which doubles the number of balls in the scene. And yeah, so when the ball falls off the map, uh, the game is over. So the game is over. And when the player breaks all the bricks, the level will be complete. So it's simple that way. The idea is simple, and we'll just break it down into some parts. So let's see. So the thing with this game, we have a player that is a paddle, right? And we have the ball. So let me just we have the ball control. Uh, so the ball basically has to bounce around, and it's preferable to have it at a constant velocity so that the player is able to uh, like, so the game is easy, right? So it's playable when the ball is of constant velocity. And then the vector reflection. So we have to combine bounce and vector reflection to simulate something that is being bounced. So I'll explain what that is. And so ball control to player velocity. So I'll explain what that is too. And then we look at the power up, how I implemented it, and the level and audio manager classes. So let's just start with the basic simple player control. So the player control is simple. You just have to press A or D or the arrow keys to move the paddle left and right. So I have implemented uh, a simple player input function, and it gets the input every during every frame. And depending upon the input, I am just setting the translate, like I'm calling the translate function. So this moves the paddle left and right. And the velocity, I'm setting the velocity by myself because I'll be using this later. So we'll come back to this uh, when we talk about this one, ball control through player velocity. So that's where we'll be using get velocity. And on collision enter, so this paddle has a collision function. So when it collides with the power up, so I've made use of I've like taken the power up controller. So the objects that contain power up controller will only be uh, like passing this if function, right? So when the power up is called, like power up is taken or like collides with the paddle, the corresponding things will be called. So for now, we'll just look at player input. So it's as simple as it is. We'll get the input from the user, the horizontal axis, and we'll move left and right depending upon the input. And up next, we will look at the ball control. So what I've done is, for the ball to bounce around, right? We have to do two things. We have to get the input direction, like when the ball is about to bounce on something, we have to get the input direction. So let's just say this is the surface, right? So the ball is coming this way, and when it touches a point uh, on the surface, we have to switch the ball's direction to the opposite side, like such that it reflects. So this like a sort of reflection, right? And for this I have used a vector function called vector dot reflect. So yeah, so collision. So the ball is about to collide, and when the ball collides, I am just getting the direction. So this is the vector to reflect function. So it gets the input direction and the collision normal. So the collision normal, basically it would be the point, like point at which we have taken like the ball bounces. So we can retrieve that by call contacts and the first contact point. So contacts of 0, and we can retrieve the normal at that point. So I'll be doing this. You can see it here. So call that. Uh, Usually this is the normal like condition, right? So condition normal would be call that contacts 0 dot normal. So at the first point that the ball touches the any surface, right? So we have to get the normal at that point. So we'll get the normal, and we'll pass the direction of the ball and the collision normal. So direction, how will I get the direction? So direction is basically, yeah, it's basically wait a second. Yeah, so here it is. Direction is the velocity normalized. So the velocity, we know what the velocity is. So it's direction and the speed. So we just have to normalize the velocity so that we get only the direction. And that's what the direction of the ball would be. And I pass this along with the normal at that point. And this vector 2 dot reflect will give me the new direction, the new reflected direction. And using this direction, I'll just giving to the velocity, right? I'll set it to arbiter velocity with speed and direction, and this will just bounce it back. So that's basically how I implemented the bouncy thing of the ball. And then constant velocity. So constant velocity is pretty easy. uh, let's see, I have yeah, so I've taken a float, right? Float variable of speed called speed. And initially, if you are like, when I play the game, the ball is stuck to the paddle, right? It's not moving at all. It moves along with the paddle. So what I've done there is I have set the ball. Let me show you. I have set the ball as a child of the player. So when the player moves, the ball moves along with it. And this is at the initial state. So now I want to launch the ball. So I just get input from the user. So when space is pressed, I just set the ball's parent to null. So what this does it, the ball is now outside of player. So I can't do this now because it's a prefab. But during runtime, the ball goes outside of the player, and the ball is able to move freely. And from there, I just have to set its direction, right? And I have to set a bool value so that I don't have to uh, check this condition again. So I set the bool value and I set the direction. So direction I set to vector 2 dot up into speed. So vector 2 dot up because I want the ball to launch upwards. So vector 2 dot up is the direction, and the speed is the value that I have given here. So this constant speed should be maintained, right? And for that, you can see in late update, I'm just multiplying the direction with speed. So wherever I'm setting the velocity of the ball, I'm giving it a constant speed value along with the normalized direction. So that's why the ball's velocity is constant always, right? And yeah, so that's basically constant velocity. And we have seen vector reflection. So ball bounce is basically we are implementing ball bounce using vector reflection. So where the ball goes on this way, so that's a vector 1. And using vector 2 to reflect, we are able to get vector 2, which is the opposite of vector 1, like depending upon the normal, right? And then ball control through player velocity. Okay, so this thing is tricky. So why I'm using, like, why did I have to implement this feature? So sometimes when we let's say, okay, so sometimes let's say the ball is coming this way, right, and you have a paddle, and the ball keeps on reflecting in the same manner. So sometimes you get stuck in a place where the ball like there's a brick over here, but you're not able to reach it by any means because the ball keeps on following the same uh, reflection path, right? So I'm drawing this because I'm drawing this to implement the bounce. So the ball goes this way, this goes this way, and maybe bounce off the like border, right? And it bounces, then you bounce again and go back. So you are not able to reach this specific brick because the reflection is all the same, right? And for this, I am doing this kind of ball manipulation. So let me just, okay. So say you have the paddle here, right? You have the paddle, and yeah, the ball is coming this way. So when I move the paddle towards the left, as the ball touches the paddle, I want the ball to go in the direction that the paddle is moving. So I want the ball to go this way, right? And say the ball is coming this way, and the paddle is now moving this way. So when the ball touches the paddle, I want it to reflect it, like bounce it back in this way, in the direction that the paddle is moving. So by this, I can able to control the direction of the ball to some extent. So for that, I have implemented a special like feature, and we'll just see that. Okay, so this is the bar brick, yeah, and ball control. Okay, cool. Yeah, right here. So ball control, and this is the condition for the pit. So like the pit is the thing at the bottom of the level. So whenever the ball touches this, it should like destroy, right? And that is what is happening here. And this is the condition for when the ball touches the paddle, right? So when the ball touches the paddle, let's just ignore this for now. It's just a sound. And so this is the case here. So what I have done here is there's another small case over here, like small test case here. So say the ball is coming this way, and I am moving my paddle this way. So what this does it usually, like if my ball comes this way and I move my paddle this way, it should bounce back this way. So this the ball is coming in the direction that the paddle is moving, right? So if I multiply, like if I add this angle to the like result angle, then I will get something like this, right? So the ball will go in a direction that is too steep, like not steep, like too flat sometimes, right? If the ball arrives in the direction that the paddle is moving. So this can be very like annoying. So the ball would just go like this. So your paddle will be here, the ball will go left and right and left. You want it won't touch the paddle, right? So to avoid this, what I decided to do is the ball only bounces in the opposite direction. Like you can only control the opposite direction bounce. So if the ball comes this way and you are moving to the right, then you will be able to control the ball to go to the right. Otherwise, if you're not moving anywhere, and or if your paddle is moving to the left, then the ball takes the normal bounce and gives the normal reflection. So you can't control that reflection, right? So that's what is basically I have implemented here. So I have used vector dot dot. So dot product. The dot product takes two arguments. One is the direction of the ball, and one is the direction of the paddle, right? So for that, I have used here paddle dot get velocity. So get velocity is what I use to return the velocity. So velocity I implemented by uh, the normal distance by time, right? And yeah, so I get the velocity and I normalize it, so I get the direction of the paddle, and I have the direction of the ball, right? And the thing is, when it's like mm, when it's less zero or less than zero, right? That's what I've written here. So when it's zero, it means that the ball is coming straight downwards, like straight down. Like let me just draw it. So when it's zero, right, ball is coming straight down, and say your paddle is moving this way, and your ball is coming this way. So I don't want it to go that way. I want it to have a normal reflection. But if the paddle is going in the opposite way, and the ball is coming in the opposite way, right? So now I want to reflect in the opposite, like the way the direction the paddle is moving. So for that, I will implement the dot product, and when the condition. So if it's less than zero, that means that the directions are opposite. So the ball is moving in the direction that is opposite to the direction of the paddle, and that condition is true. When that condition is true, I just have to add the paddle's velocity. I just have to like yeah, I just have to add the paddle's vector, like direction vector, and I'm giving it a random like variable, so that it doesn't always come back in the same direction, right? So why I've done random not range, I'll explain that too. Mm, okay. So let's say there can be like three cases. So I'm moving here, moving right always. The ball is coming wait, the ball is coming this way, right? And I don't want it to go this way every single time. So instead, I've added a random float, so that it I have multiplied a random float so that the angle not this steep, but it's somewhat different each time, right? So that's why I've added this float. And otherwise, like if the directions are same, then I just have to take the normal as it is, and yeah, so I'll just do the normal reflection, right? And that's basically what I've done for player control through player velocity, ball control through player velocity. And like at this point, you'll be able to control the ball very like as you like. And yeah, so the next part would be the bricks. So I forgot to add that on. So bricks. So the bricks is the goal of the game. So you have to break all the bricks to win the game. And for that, what I've implemented is a simple. It's simple. So brick, right? And I've used a brick type. So this is just for specifying which type of brick it is. And capacity. So this is what defines the capacity of the brick. So the higher the number, the more number of hits it can take. So when the capacity reaches zero, the brick should explode or destroy itself, right? And I am just setting the capacity depending upon the brick type. So brick type is over here, right? And the text. So text is for showing the player how much more hits it can take. And this is a prefab for the particle effect that it should play at the end of when the brick explodes. And this is the game manager reference, right? So let's see on collision enter. Yeah. So if so a brick will always get collided by the ball. So I have set the collision matrix as that uh, only the ball can like hit it, not any sort of power ups or anything. So when it gets collided, if the capacity is more than zero, I just decrement the capacity and update the text. So update text is basically I'm changing this text value to the capacity, right? And if the capacity is now zero, that means brick is no longer able to take any hits, so it should destroy itself. So I'm just calling the game manager delete brick function. So we'll go to that up next. So delete brick, and I'll just instantiate the explosion particle effect, right, at that specific position. And finally, I'll destroy the game object. So this delete brick is what we have to count the number of bricks in the scene, right? So at the start of a level, we might have 20 bricks. So we have to count the number of bricks that are being deleted, so that at the end of the level, like when all 20 bricks have been deleted or destroyed, we know that the level is complete. So for that, the game manager uh, takes this delete brick function, right? And yeah, so that's basically brick controller. And what else? Okay, power up to export level manager audio. Okay, before we move on to power up and the other stuff, I'll just go through the game manager class. So each level has a game manager class, and for now I have only implemented one power up, but I can implement multiple power ups in later on. So I've used enum, and let's see. So canvas controller is for the pause menu, uh, the game over menu. So those UI stuff are done by the canvas controller. So I have a reference to that, and a ball prefab. So this prefab is instantiated when I want multiple balls in the scene. So that's that. And power ups. So uh, a list of all power ups that I can have in the game. Like these are all prefabs, and when I want to spawn power up, I just spawn using this prefab, one of the prefabs in the list, right? And a ball list. So I have used a ball controller, like list of balls, right? And we'll look at it later on. And a pop-up force. So this is for the power up, right? And game passed false. So game passed is for tracking whether the game is passed or not. Brick count. So this is what I was talking about. So at the start of the level, the brick count is set to the uh, number of bricks in the game, in the scene, right? And when that brick count reaches 0, the game is done. Game is over. Like the level is complete. And let's see, ball count. So the number of balls in the scene, and power up count. Okay, dex count. Okay, so we'll just go through the important stuff. So there are lots of like auxiliary functions like level fail, level complete. So these just call the appropriate UI like functions and freeze the game and stuff, right? Uh, let's see. Okay, delete brick. Yeah. So delete brick. We saw here that when like brick controller. Okay, brick. Yeah. So game manager delete brick is called at and the position of the specific brick is passed, right? So delete brick takes the position. So this position, I'll tell you why we are taking this position. This because we want, sometimes we might want to spawn a power up, right? So for that we need the position of the brick. So that's why I'm passing the position. And if brick count is greater than 1, I just decrement it. If it's not, like, which means that brick count is equal to 1, right? And when that uh, brick gets deleted, it means the level is complete. So level complete is basically, it calls we just looked at that, it just calls the UI function, and freezes the game, plays pauses some music, plays the sound, right? So let's see, delete brick is done, and spawn power up. So spawn power up, I have to do this. I have set odds of 1 out of 10, right? So 1 out of 10 times the like power up gets spawned, and Yeah, so spawn power up and it takes the position. So for this, right now I just have one power up in the power ups list, but we can have multiple in that list. So for that, I've used a random range from 0 to power up count. So any one of the, say we have 10 power ups, then any one of the 10 power ups would be set as the index. And for now, I just have 0 and power up count is what, 1, I guess. So range takes mini inclusive and max exclusive. So 0 to uh, what, 0 again. So index will be always 0 in this case, but later on we can implement more power ups. And if the index is less than the power up count, then I just instantiate that specific power up with the index and give the position and the rotation, right? Uh, Then I just set get the rigid body component, add force, and I give the pop-up force. So it just pops from the, it looks as if when the brick breaks, right? The pop-up has popped from that break, like from that explosion. So that's why I've done this. And yeah, so that's basically spawning the power up. And later we have power up picked, right? So I have a power up controller here. So when the power up collides with the player, right? So where is it? My bad, player, right? Yeah. So when the, we looked at this. So when the collides with the power up, I have to call game manager power up picked, and I have specified which power up it is. So I just do that using get power type. And yeah, so instead of this, I guess I could just do uh, in get power type, right? Yeah, but time dot get power type. This should be just fine. Yeah, so I just get the power up type from the power up, and I pass it to the picked game manager. And the game manager now knows which power up I am picking up. So depending upon the case, I'll just call the specific power up function. So that's basically how I'm managing power ups and spawning the power ups, right? Oh, cool. Let's see, have I missed anything else? Delete ball. Okay, delete ball. I guess we'll look at delete ball later. Cool. So now we'll look at the power up. So 2x balls. So the idea of this power up is to double the number of balls in the scene, right? So when the power up gets up, if there are 2 balls in the scene, they become 4, and if there are 5 balls, they become 10. So likewise, and let me just show you. So the this function that is called when the power up is picked. So okay, so cool. This is a ball list. So I'll just explain what the ball list is. So the ball list contains the number of, oh my god, 1 second. Yeah. So ball list contains the number of balls in the game. Like it contains all the references to the balls in the scene, right? And this is how I have done it. So I create a new list, and this refresh ball list will basically it will get all the items with type ball controller, right? And it will add it to the ball list. So ball count is the count of ball list. So this is basically I'm use this for debugging. So I know I can like track how many balls are there in the scene correctly, right? And so you just have to know that ball list, this list contains all the like the list of all the balls in the scene. And when I have to double the balls, I just have for each ball in this list, I have to instantiate another ball. So that's the only thing I have to do. So for each ball in this template. So what happens here is I used a new list, right? So the thing is I can't traverse this what OG ball list and like change it at the same time. So I can't do that. So for that, I have created a new template, and this template contains all the it contains the same values as this ball list. And for each item in this temp list, I'll be creating a new ball. So I'll instantiate using the ball prefab, and basically I'll just uh, yeah. So new ball controller just spawned new ball controller set direction. So I'll show you what this is it, and basically I'll just create a new ball, and I'll increase the ball count, and I'll add it to the ball list. So that's all I'm doing. So create new ball, increase ball count, and add it to the ball list. So that's what I'm doing. At the end of like for after creating each extra ball for each ball in the temp list, uh, I'll just like that's what I'm doing, right? I'm just creating one ball extra for each ball, and we look at what this is, and okay, so just one. The thing is, when I'm creating a ball, right, we had looked at the ball controller. So in the ball controller, uh, I have it this way, like the ball stays attached to the parent class, like the parent in the sense the paddle in this case. But for a ball that is uh, instantiated separately, I don't have to follow the same rules. So that's why I immediately after creating this ball controller like object, what I do is I call this just font function. So what it does is it sets the launched bool to true, and index. So index is basically for identifying the specific ball. So for instance, this is index, and the next one would be uh, let's say, yeah. So then next one would be 2, right? So next one will be 3. So what I've done here is I've set launch to true, which means that this won't be considered, right? Like this won't be checked, and I'm sorry, this will be false always, right? So this will be false always, and the ball is able to move freely now. And here I'm setting the direction to -1 into item dot get direction. So what I'm doing is I'm getting the ball's like direction. So say this is the ball, and it's going this way, and I have now picked up the 2x power, right? 2x ball power up. And what this does is I want to instantiate a ball in the same place, right? But it has to go in the other direction. So when this happens, right, it looks pretty cool. So the ball, the ball that was going already will go in this way, and the new ball would be going in this way. So it looks pretty nice, like it popped up from itself, like it split itself or something like that. And let's see, yeah. So that's why I've used -1 into get direction of the ball, right? Item in the sense the ball, the current ball, and this is for like this is like quality of like the ball, because it was in the player under the player, so the player's x axis is doubled, and so the ball's x axis is halved. So when I'm using this to instantiate, what happens is the ball turns out to be, let me show, it turns out to be wait it turns out to be like this when I instantiate. So for that, I reset the like local scale values to 1, and it remains it looks normal then, right? So that's basically doubling the balls, and when I'm doubling the ball, I'll have more numbers, like the ball count will increase. And this is where we have the important delete ball function. So the delete ball is called when the ball reaches the pit, right? So here you can see delete ball is called when the ball collides with the pit. And this is important because this is what will get you to the failed condition, level failed condition. And yeah, so we look at what is happening here. uh, Whenever a ball is getting deleted, I just send its index, right? So the game manager also has an index count, and the ball control ball, each ball also has an index. So I'll just go through all the balls in this ball list, and I'll compare its index with the index that is present in that is passed through this ball, right? And if those are equal, then I'll just remove that index, like remove that ball from that list and delete that ball too, right? So that's what I'm doing here. So I equal to ball list that find index item, where item whose index is equal to the index passed by the ball, right? And once I have done removing, I'll just decrement the ball count. And if the ball count is now 0, that means that there are no balls in the scene and the level is failed, right? So that's basically deleting the balls. And yeah, so that's we have done pretty much it. This is for like pausing the game on pressing escape. And yeah, let me see. uh, Ball control, bricks, power up, we have finished one. So level and audio manager. So this I have implemented level and audio manager as singletons. So level manager, right? These are implemented as singletons so that I can access loading next level and restarting level from any scene just by using the class name, right? And same thing goes for audio. So audio manager has two game objects under itself, like as child objects. So two audio sources and a list of sounds. So I have created a class which contains a sound type enum and a audio clip, right? So for each sound, this sound is serializable, so you'll be able to create new sounds going forward. Like let me show you. Yeah, so this is a list of sounds, and I can set the sound type, so which is this is an enum, and I can set give it a separate audio. So I can just call the play sound function. So you can see here play sound function, and I'll just pass in the specific sound type, and depending upon what the sound type is, the specific audio will be played from one of the audio sources. So that's basically my whole game. I will implemented some 5 levels. You can try it out in the link, and I hope you had a good time. Thanks for watching. Bye bye.